math homework. We have a lot going on today that we'll tell you about in a minute, but let's tell you how to contact us.
Okay, one way that you can contact us at Count on Us is by phone 301-772-0080. Another way you can do it is by email, and that's of course COU@PGCPS.org.
Now, hopefully you're watching us on either channel 96 or channel 38 right now, but if you're just listening to us and you don't have a TV to monitor us because you don't have cable, what you can do is stream us in live, and that would be going to the www.pgcps, Prince George's County Public Schools.org, and then go to live streaming and you'll see our show, Count on Us, and you can join us that way as well. All right, so they're going to contact us while they go over their homework. We're going to go over some challenges. We'll start with the one that you guys love the most, Challenge 24.
Challenge 24. You showed me this last time, but it's been a while.
All right, then we'll show you again as we show all our students out there.
Okay.
Challenge 24. We have a card. It has 4 numbers on it. We want you to copy down each of these numbers because your challenge is to use all 4 numbers once each and use any computation, addition, subtraction, multiplication, and or division, combinations of them, to make these 4 numbers come up to 24. So card A, write down card A, you have an 8, a 2, this is a 6, even though it looks like a 9 the way it's facing. 9s are filled in with a red dot, okay? So this is 8, 2, 6, and a 1.
All right, and then we have card B here. And our numbers for card B is 7, 4, another 4, and 2. So once again, that's 7, 4, another 4, and 2.
And you do have to use each 4. So you can't just say I use the 4. You have to use both 4s. Card C, 5, here's the 9, 4, and 8.
And card D, 3, 3, 3, and 5. Uh-oh, that's going to be kind of hard.
Now, a couple of things. Speaking of kind of hard, you notice there's 3 dots on the card that Mr. Johnson said looks kind of hard. Well, 3 dots means it might be a little harder.
Okay.
And I say might because sometimes students look at these and find these to be very easy. According to the company, the 1 dots should be the easiest to manipulate the numbers to make 24. The 2 dots, a little more challenging, and the 3 dots should be the most challenging for you. Please remember, every Challenge 24 card has at least 1, but most of them have more than 1 correct solution. So when other students call in, listen to their solution. If they say, I want to solve card B, don't say, oh, he took my answer. Listen to what they're saying because you may have come up with a different solution for the same card.
All right.
And I'm going to throw one strategy out there to begin with because the first thing you want to do is add all 4 numbers because some of them are going to equal 24 just by adding them up. Not all of them. And I'm even going to do card A for you because I have an 8 and a 2, which is 10. Here's a 6 is 16 plus 1 is 17. So the sum doesn't get us to 24, which means I have to do some manipulating of those numbers. Maybe I'll add or multiply 8 times 2, which gets me 16, a bigger number, and then add the other numbers. Maybe I need to subtract this from this to get a number. So manipulate the numbers, use all 4. When you come up with 8 plus 2 is 10, you now have the 10 that you can use with these other numbers. So you also can use your answer, whether it's the product, the sum, you can use that to help you solve the challenge.
So, Ms. Sternberg, if someone calls in and they get it right, what happens then?
Oh, well, just by calling in, we write your name on the yellow piece of paper, and it goes into our treasure chest, which gives you an opportunity to win a prize at the end of the show.
Uh-oh.
If you get the challenge right, your chances
Double the
fun, double the chances that your name goes in a second time. So 2 chances is better than 1. I hear the lotto, the Mega Millions, didn't get 1 last night, so it's up to like $400 million.
All right, 400.
The more chances you have, the better, and your chances are way, way better than those at 400 million because there's a ton of people. The likelihood of winning that lottery is very, very, very tiny.
All right.
All right, we have other challenges going on as well. This challenge is a mind builder. I love mind builders, similar to things that make you go, where you have to think about.
Okay.
This is a think about.
Let's see. Mind builders. 5 students are standing in line. 3 are boys and 2 are girls. The 2 girls always stand next to each other. How many different ways can the 5 students line up? All right.
So you're going to think about this, figure out a strategy of how you might want to attack it so you can give us, and you can start by giving us some of them, and we'll see if by the end of the show we can build all the different solutions to this problem. We have some students lined up down here, so you just tell us how you want to line up your students to show us that it meets the criteria. Have to have 5, have to have 3 boys, 2 girls, and you have to have the 2 girls next to each other.
Okay.
So obviously there's more than one solution. How many are there?
And how many do they need to get it correct? If they can give us one, or
I'll take one. We'll take one and put their name in again. The more the merrier. So let's see how many, because I really don't know the solution yet to how many there might be. One more challenge.
What's my number?
Keep reading.
I am a 3-digit number. My tens digit is 5 more than my ones digit. My hundreds digit is 8 less than my tens digit. What number am I?
So I love these because you can make these up so quickly and easily for your friends. I know I told you one other time, I'm kind of a math nerd. My friends say, oh, but you love math and you love puzzles. I do.
I do too.
But to sit and challenge someone by saying, all right, I'm thinking of a number. Well, if I say I'm thinking of a number from 1 to 10, that's no fun. You're just guessing random numbers.
7.
But nope, that's not what I was thinking. But if I put a challenge on it and say to you, I'm thinking of a number between 1 and 100.
Okay.
If I say it has 2 digits that are consecutive, do you know more than a random guess of 100 numbers?
I do.
Okay, so by that, just like this, what's my number, you can use the process to eliminate numbers.
Okay.
And we're going to have some callers on the line, I think. And what we'll do is start talking about that as we take our callers so we have something to talk about. So
all right.
I'm looking at a number between 1 and 100. And we're going to hold that thought, take our caller, and come back to that thought.
All right.
Can you hold the thought in your head?
I got it.
All right. Because I know when you get to a certain age, sometimes the thoughts don't stay.
Not too well. Not too well.
But let's see who's on the line. Feel free, Mr. Johnson.
Hello, you're on Count on Us.
I'm not hearing anyone.
Me either.
I think they're tricking us.
Hello.
This is Count on Us. Do we have anyone out there?
Oh,
we lost them.
Lost you. Oh.
All right. Well, we'll go back to that thought we were holding and come back to our caller if we get them back. So, thinking of a number from 1 to 100 means we have 100 random numbers you could choose from.
Right.
You haven't? Take a guess. Any idea?
7.
7. 7 must be your favorite number.
It is.
It is. So I'm going to tell you it's not 7.
Uh-oh.
And we can continue this without you having any clue, just randomly guessing. But if I tell you that there are 2 numbers or 2 digits in my number, that doesn't help that much, but you can eliminate some numbers. What can you eliminate?
All the single digits.
All the single digits. So we're going to eliminate 1 to 9. Can't be.
Go.
And
2 digits.
The 100. It has 3 digits. I didn't say between 1 and 100, which would mean I said from 1 to 100.
Right.
So we can also eliminate the 100.
There we go.
So now we still have a lot of numbers left. These are great things to do on a hundreds chart. I wish we had one here to show, but then we can cross out numbers as we eliminate them.
Right.
But if we look here now, I said they're 2 digits and I said they are consecutive. Consecutive. Am I spelling that right? Consecutive numbers. It's looking funny. Consecutive numbers. Mm-hmm. All right. So now, what does consecutive numbers lead you to?
I know they're going to be in order.
Okay. So I didn't say which one was higher, which one is lower, which I will. But right now, give me an idea of what the numbers might be. Again, if we had our hundreds chart, we could look at the numbers. But as we're counting, we know we can't use 1 through 9. So 10.
10.
Could be 10. They're consecutive numbers because 1 and 0 come after each other. Didn't say which way they were. All right. What else might be consecutive numbers?
45.
So you're going to do them randomly. I like to do numbers sequentially. So I would have done a pattern, but go for it. So what would you do next?
Let's see.
I'll put 45 over here.
Let's go with 56.
56.
Let's go with 23.
20. See, now we're going back to our 20s.
Let's go with 34.
34.
Let's go with 67.
67.
And 89.
89.
Is there anything else? Let's see. 1, 2. I don't know. Is there anyone else? We got the 1.
Now, I guess I'm asking, would consecutive numbers, 8 and 9 are consecutive if we're counting 8, 9. Would 98 be consecutive
98.
numbers?
Oh, that's right, because we didn't know the order.
Right, so we don't know the order, so we have all of these.
Flip them all over.
Exactly. So the 1 and 0 would be a 0 and a 1, so that one
can't use that.
Can't use that one. One more in the tens place.
11, 12.
12.
12.
So 12, 1 and 2, and then we reverse that to be 21.
And then 54.
54.
65.
65.
32.
32.
43.
43.
76.
76.
Okay. We already did
89 and 98. Now, my next clue. I love using clues and working out the process of elimination. The tens place is lower than the ones. Lower or smaller than the ones place.
Okay.
So what can we eliminate?
We can eliminate the whole bottom row.
Ah, the whole bottom row, because the tens place is larger or bigger. Gone, 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 gone.
98.
And 98.
Okay. So now 10 can also be gone.
10 can also be gone.
Okay.
Now, how about I say my next clue, and I'm running out of space for my clues, but I'm going to say my digits, when added, become a 3-digit number. Wait a minute. I didn't mean to say that. My digits, when added, become a 2-digit number.
Okay.
I meant to say 2-digit. So when you add my digits, it becomes a 2-digit number.
Okay, so 12 can be eliminated?
Because when we add digits, and this one confuses students a lot, when we add digits, 1 plus 2 equals 3. So that can be eliminated.
45.
45, because 4 plus 5 is 9, 1 digit.
23.
23.
34.
34.
Okay.
And he should get it on my last clue. My last clue are the 2 digits are the same.
The 2 digits are the same.
When you right, from this clue here. So when you add my 2 digits, the new 2-digit number, the digits are the same.
56.
56 was when you add this, it becomes
11.
11, 1 and 1.
Oh.
Let's check 8 and 9 is
17.
Can't be. So even though we think we got the right answer, we want to make sure that other answers aren't correct as well. 6 plus 7 is
13.
13, leaving only one number. So this is actually, what a nice feeling when you're on a hundreds chart and you're crossing out and you're crossing out and you get down to only one number.
Right.
Cool. So this is similar. What's my number? So again, you're looking for a 3-digit number. The tens digit is 5 more than the ones digit. The hundreds digit is 8 less than the tens digit. So the only thing about doing what's my numbers or guess my numbers is that you have to make sure at the end there's only one number that can be the possible solution.
Okay.
All right. So what else would you like to talk about?
You know, I was out visiting schools today, and
Excellent.
a lot of the topic was fractions. Oh, fractions are everywhere. And they were building a garden in 3rd grade. So I know my 3rd graders over at Baden. I know you're ready to call in for me. Come on, 3rd graders at Baden.
And they're building a garden. Were they using fractions or were they using the perimeter?
They were using area.
So tell us a little more about that.
So we were working on how to build a garden. And they had to do 2 arrays first. So they started off with arrays, and they wanted to give only 30 tiles.
Okay, so you're doing an array, and you're doing 30 tiles.
30
As soon as I think of array, I'm thinking of length times width.
Length times
I'm thinking of my spacing, of setting up some kind of a square or a rectangle, whether it's that way whether it's long and short, either one. Sometimes I would make them even, but when I think of an array, this is what I'm thinking about. And I'm thinking about equal numbers of rows and columns.
Right.
Okay, so that's what you should think about when you hear the word array. You're actually thinking of your times tables, so it's something times something is going to give you your array. All right, so this is an array of 30, and they needed to show it two different ways.
They needed to show it different ways of how they can use their 30 tiles, and they must have two different gardens. But when you put the two together, they had to total the 30 tiles being used, and they both had to be different sizes. So just to see the kids working with it at the very beginning, because that was just the first stage.
Okay.
And then they moved them on. Now, if we put them in the middle, what fraction would that lend for us? So it was just amazing to see the kids thinking of how to use fractions. But a lot of them was having problems with, how do I relate the fractions to what the tiles were showing me in the array?
Were all the tiles the same color?
And that's where they were getting their fractions from, because the tiles were all different colors.
Okay. So, do we have tiles?
We do.
We do. Excellent. We have some tiles. So let's model it out, and let's see the kids from Baden. Hopefully you will call us. Okay, now we have got all different sizes. We actually have fraction tiles, don't we? Mm-hmm. So I wonder if we'll have 30 of the same size, because that's one thing about an array. All your pieces have to be the same size.
Have to be the same size.
So I've got 2, 4, 5, 6, 7, 8, 9, 10, 11, 12. Actually, when I had 10, I'm 1/3 of the way there, because 10 plus 10 plus 10 is 30. So in groups, it's 3 sets of 10. So here's 10. Here's 2, 4, 6, 8, 10 more. And then I have 1 more. Can you make 9 more anywhere? Uh-oh.
I think we're a little short on the other one. So we can start off with 20.
I was going to say, maybe we'll just solve a simpler problem. We're going to change our number for our array. We're going to make 20.
Okay.
I'm going to pull 1 out. All right. So now we have an array, or we're going to make an array using 20 tiles. They're the same size, so I'm just going to put them in a kind of a row right now.
And the first thing came to mind for the children were 1 times 20. So they all put them in one long row.
Oh, one long row. I don't want to. But you can. We can put them in one long row, but I don't like the one long row. I'm looking at colors here, and I just don't want them just willy-nilly or hodgepodge or random. So I want to kind of put them so my colors make a little bit of sense to me. So I don't have, keep going with blues. I'm going to put 2 reds on this end. So 2, 4, 6, 8, 10, 12. I know because I have a number 20 that my number is even, so I'm going to have an equal pair. Every one is going to have its partner. 2, 4, 6, 8, 10, 12, 14, 16, 17, 18. Well, we have... Actually, you know what I'm going to do? I have one more green. I'm going to put the green one here. And this way I have the same number of blues. All right, so first of all, we made the array. Okay? The colors right now we're not going to look at. We're going to look at the array. And we know you said we could make an array of 1 long row and 20s in that row.
Right.
So 1 times 20. Okay. And anytime I have a math multiplication, I can always reverse it. 1 times 20 is the same as 20 times 1. So I could have my long array going this way, 1 in the whole row and 20 across, or I could have it going down, almost like rows and columns. And my 20 can go all the way straight down with 1 in each row, 1 column, 20 rows.
And what property did we name that?
Well, I would say I'm kind of going work to home, home to work. So I'm commuting?
I'm commuting?
I'm commuting.
I know that's a good one.
All right. When we go to work, I go to work every day the same way. I go from here to there, and then I go back again from here to there. Okay. So I'm reversing it. We also use the fact families or the commutative property. Mm-hmm. All right. Then we put them together where, because we knew it's an even number, and even numbers we can put in partnerships, we gave each one of these a partner, and we made 2 rows with how many columns? How many are in each row?
10.
10. So 2 times 10 is 20. And we could do it this way, or we could take this whole thing and turn it this way. And now we have rows go across horizontally. So now we have 10 rows across. And how many columns do we have?
2.
2. So now we have 10 times 2. Again, that same property. Work to home, home to work. Commuting. The commutative property, back and forth.
Okay.
All right. Now, well, let's see. We did 1, we did 2. Let's see if we can make 3 in each row. And we know that every time we make a row, we have to have the same amount in each row. So let's see if we can make 3. Uh-oh. I have all these here, but you know what's happening? I have a space here.
So that means 3 is not.
So 3 will not make an array for the number 20, which means if these are our math facts, okay, these are facts, these are factors of 20, 3 is not a factor for 20.
Not.
We cannot make 3 in a row. Let's see if we can make 4 in a row. If I take this one here, now I have 4 rows. So let me make a combination of 4s. Oh, I like what I'm seeing. I have 4 rows across. I have none left over. I have the same amount in each row in each column. So 4 is a factor of 20, and it has a partner. And look, I'm setting this up like an algebra problem.
There we go. Where's that unknown? There we are.
Here's our unknown. What number goes here? 4 rows. How many are in each row?
5.
5 in a row. So we have 5 columns. 4 rows times 5 columns. And then we're going to commutative property it, switch it around. Fact families as well. You guys learned those. 5 times 4. And it's going to equal, if you have the same numbers, it's going to equal the same number of tiles. We've never changed our tiles. I love it.
Okay.
Let's try 6. Might as well keep going. Whoops. So here's 6. Now I'm going to take these over here. 1, 2. Oh, no. Now I'm trying 5. And we actually know already 5 is going to work because we just did 5 is going to be 4 in each row. Now I'm saying to myself, wow, that's working for 6. That didn't make sense. But I had to check my own thinking. 5 across down times 4 gives us our 20. Now we'll try the 6 rows. And because I know my math facts, I already know what's going to happen here. I can fill all these in with my 6 rows, but I have 2 extra pieces.
Right.
Not
So
going to work.
6 not going to work.
Because 6 times 3 is going to give me my 18, 19, 20. So 6 doesn't work. So right now we know 3 was not a factor. 6 is not a factor. And actually 3 plus 3 is 6. That kind of makes sense. All right. Next number would be 7. So I'm going to make 7 rows across. I'm missing one. So I don't have enough to put 7 in each row. Again, knowing my facts, I know I only have 20 here. And if I have 7 times a number, I know 7 times 3 is 21. So I'm missing 1. I only have 20. So 7 is not a factor. And we said 3 is not, 7 is not. Next number is 8. Let's continue on. Here's 8. So let's move these. Oh, now we have all of these missing.
Right.
So no way 8's not a factor. Let's continue on with 9. Moving these 2 here.
And we still have 2.
We have 2 left over, so 9 doesn't work. But when we move these 2 to make 10, we know that works because we already did.
had.
There it is, 10 times 2. So this is great. The younger students are learning how to make arrays, and I think we dropped one down there, but let's pull this back up in here. So the younger students, as you're learning to make arrays, you're learning your math facts. You're learning how to put together the facts. You're learning those fact families, but when we get older, we call it the commutative property. 3 times 4 is the same as 4 times 3, or sticking with our number 20, 4 times 5 is the same as 5 times 4. And then what happens is we're actually showing ourselves how to make factors. And those factors, the 24 challenge gets solved by knowing factors. Let's look real quick over here. And here's the numbers we said. Well, my old Texas T.
Texas T.
Every number has 1 in itself, which means we made that one long row of 20. Then, if it's an even number, it always can be divided in half, 2 times 10. We have that right under here. 3, no number times 3 is going to equal 20. We already said 3 is not a factor. 4 was not a fact. I'm sorry, 4, we made 4 rows of 5. Excellent. Which means 5 is a factor, 4 is a factor. Our next counting number is 5. So that means these are the only factors. 3 would not be, 6 would not be, 7 would not be, 8 would not be. We don't even have to do all our testing because 1, 2, 4, 5, 10, and 20. 1, 2, 4, 5, 10, and 20 are our factors.
Yep.
I love it. So we just showed how students progress from hands-on, tactile, touching, using manipulatives, all the way up to that more abstract thinking where you're doing the numbers in your heads. So in the beginning, we love to have you work with the numbers and using manipulatives, but once you get and become experts at it, you become efficient mathematically, then you move to the more flexible thinking.
And they were working it. And they were working their hands on, but then all of a sudden their teacher threw in, now look at your colors, boys and girls.
Ah.
Now, how will we say how many yellow are inside your garden? So now the
tell us
students
more
had to
about
look.
that. So
So
let's
now-
turn this. Let me take this mess off and let's put this on here. And let's use the array of 4 by 5 because that puts it neatly on the paper.
Okay.
So let's put them together. 4 rows of 5 columns.
Mm-hmm.
Slip yours right in there with mine. Whoops. All right, so now we're slipping them in here. And we did our colors randomly this time because you know what? It doesn't matter.
Mm-hmm.
Right now we know we have 4 rows of 5 in each row. So we have 4 times 5. But now Mr. Johnson threw a little wrench in the oil here. I don't know if that's the right saying. How does that go? Do you know that saying?
Threw a little wrench in the oil.
I don't know. We'll skip that saying. I don't know how it goes.
Threw a little monkey wrench.
Monkey in a wrench at the monkey?
Oh my God.
I don't know how it goes. Let's just do this.
All right.
So you mentioned something about yellow.
Yellow.
All right.
So now what the teacher asked was how many yellow would be inside your garden. So the kids looked and they knew. All I had to do was count. 1, 2, 3, 4. So they knew 4.
4 are yellow, but I need, if you said a fraction, out of my
Yeah.
total, and we don't have to count. Please don't count because we already know.
But you should, the kids, they were working and they was thinking to themselves, well, I have 4, but then they decided I only had 1 in each row. So they were putting 4 over 4. So I was a little confused of where the 4/4 was coming from.
Tell
And they
me more,
told
'cause that's
They said,
confusing
well,
me.
look, I have a yellow in this row, a yellow in this row.
Column. So we're going columns now? Or you mean across or up and down?
We're doing columns.
Okay.
I have a yellow in this column,
Okay.
a yellow in this column, a yellow in this one, and a yellow in this one.
All right.
So that would be 4 as my denominator. And I asked students, so tell me more of what your thinking is. And they wanted to know, well, I just had to have the yellows counted. I didn't need the other colors.
Oh.
So they were not understanding that everything was part of this entire whole. And this fraction that they were making was going to be part of the whole.
So this garden is our whole entire fraction, which is why we need to make sure we know the bottom of our fraction, our denominator, is always the total altogether. So you already told us, plus we did the counting of 4 rows of 5 in each row, which 4 times 5 equals 20. So our total, our denominator, which is always the total, is 20. And then if I'm counting yellow, I'm going to say 1, 2, 3, 4. 4 out of the 20 are yellow. All right. So we're going to come back in a few minutes and we're going to count the other colors. Maybe you'll be starting to count them right now while you're checking out your homework and getting ready to call us. That number is
301-772-0080.
Please watch the announcements coming up and the mini lessons that are coming up. Get your homework ready. Give us a call, and we'll be back in a few minutes.
See you in a minute.
Hello, my name is Jessica and I attend James Ryder Randall Elementary School. I am in the 5th grade. Today, the math problem is, during some months, Earth revolves around the sun in 30 days. How many seconds is this? Well, there's 24 hours in one day. So in order to find the hours in 30 days, I must multiply 30 times 24, which equals 720 hours. In order to find out how many minutes are in 720 hours, I have to multiply 720 times 60 because 60 minutes equal 1 hour. And that equals 43,200 minutes. Next, in order to find out how many seconds are in 43,200 minutes, I must multiply 43,200 times 60, because 60 seconds equal 1 minute. And that equals 2,592,000 seconds. So 30 days equal 2,592,000 seconds. Woo! That was a lot of seconds. I hope you found the solution to your problem easy to follow. This is Jessica from Counting Us. Bye. See you next time.
Hey you, yeah you, stay right there, I gotta tell you something. I bet you know someone with type 2 diabetes. Guaranteed, you know why? Because 1 out of every 3 little kids is gonna develop diabetes in their lifetime. That is can lead to heart problems, strokes, and even blindness. I'm John Sally, and I'm telling you, it ain't gotta be that way. Now you can up your defenses by eating more fruits and vegetables, having more vegetarian and vegan meals. These steps can be the power plays to protect you and your family against the risk of diabetes. To learn more, go to blockdiabetes.org. Okay.
He was so inspiring.
He took chances.
He was so moving.
He lived daringly.
Martin Luther King Jr. was a man of service, and his day shall be a day of service.
He inspired us in words, but he led us in deeds. To honor him, let's do the same. Go to mlkday.gov and find out how to volunteer on Martin Luther King Day and beyond. This message is brought to you by the Corporation for National and Community.
Okay, guys, ready? Here we go. Let's smile and brush our teeth twice a day, every day. Let's smile and floss our teeth once a day, every day. Let's keep that smile a happy place on your face with good nutrition and dental visits. Let's smile. Let's smile. Let's smile. Let's smile.
Welcome back to the elementary edition of Count on Us. I'm Miss Sternberg.
And I am Mr. Johnson.
And we have been doing a lot of talking. We're looking to talk to you. We're looking to help you with your math homework. We're looking for our frequent flyers, our frequent callers to give us a call. We got a couple of regular schools like Turkey Lane.
Hey,
Templeton, where are you? Miss Walters said she told you to give us a call, so we're waiting for your calls. We did have a couple of calls that tried to come in, and then they got disconnected. So lines are open. Try again. And in the meantime, I'm intrigued with this fraction, so let's go back to it.
All right.
So this represented the yellow. I'm labeling it so we know what fraction we're representing here.
Okay.
And I see some other colors.
I do too.
So
now we can always start with knowing that our denominator is 20.
Okay.
Looking at this problem.
Excellent. So every time we write a fraction related to this whole, we know it's 20 because there's 20 pieces.
And then everything else would just lends itself to the counting of the color.
Counting of the colors. So the easiest one looks like red to me.
And red has 2.
Out of 20, so 2 20ths.
2 20ths, and then we will write 20 again somewhere else.
Let's move over here.
Okay, the next one will probably be green.
Sure, let's do the green.
And that will be 1 2 3.
3 20ths.
All right.
And the next one, I'm droppy today. The next one, here's what I'm going to do. I'm covering this whole fraction up. Because I am going to make Mr. Johnson do some work.
All right.
Mr. Johnson, you have the yellow, you have the red, and you have the green.
Okay.
And you know the total.
So since they're all from one whole, I can just add the top numbers, my numerators. And so I'll add 3 plus 4. And
3
get
plus
7,
4. So green plus yellow is 7.
And plus the red.
Plus the red.
Will be 9.
Will be 9. So
9
red, green, and yellow
20ths.
together is 9/20ths, which means everything that's left
Has to be blue.
has to be blue.
So there's several ways I could go. I could go through adding on, counting up, or I can subtract.
Your choice. What do you like?
20 take away 9.
All right. So he knows that 9 are what's already accounted for, which means everything left, 20 minus 9, is going to be
Blue. And
blue,
that's
which
11.
is 11. So I'm going to erase this for a moment. I'm going to say that 11/20ths are blue. And check this out. This is one of my favorite things. If we add these two fractions together, the blue plus the green, yellow, and red, what's the total there? 11 plus 9 is?
20.
And our denominator is?
20.
20. And every time I taught my students, I'm ringing this bell.
Uh-oh.
Because we used to say ding, ding, ding. Every time we see a numerator and denominator that are the same, it means we have the entire thing. Ding, ding, ding.
Ding, ding.
It's a whole. It's a whole. And we would put a 1 around it because we knew even though we're saying 20/20ths, it sounds very big. It's one whole.
It's one
So if this was a candy bar, it's one whole candy bar that we're breaking into all these little squares. And I'm going to tell you now, I'm a little selfish. I'm going to take the blue pieces of the candy bar and I'm going to give you all the rest. Isn't that nice of me? I'm taking only blue and I'm giving Mr. Johnson the red, the yellow, and the green.
And that sounds like I'm getting a lot because I'm getting 3 colors.
You got it.
No, we're going to have to go back and look. All right. Okay.
So yeah, I'm being a little tricky here because we already know that the blue has the most, even compared to yellow, green, and red all together. But this is great. Our thinking, using manipulatives, and you know what? We're talking third graders here that are using the manipulatives, but if you need to use manipulatives to see something, 4th grade, 5th grade, you know what? That's okay. Sometimes I tell you guys all the time that I like to do math puzzles, brain teasers. Sometimes I really have to get some material, manipulative, to map it out and help me think through it. The one we gave you, what's my number? I would guess and check and be putting numbers down for this one, so I'm not doing the whole thing in my head. Our mind builder, 5 students are standing. I would have to draw this out and look at the pattern. Again, I like to organize, so I would use a pattern for organizing this.
Okay.
But when I'm doing Sudokus, those puzzles, I am constantly mapping out my numbers, what it could be, what it won't be, so that it helps me with my thinking, and I have a workspace where things are organized.
All right, that trial and error, that's a great strategy.
All right.
Uh-oh, do we have a caller?
We have a caller, not do we. Let's say we have a caller.
We have a caller?
All right.
Hello, welcome to Count on Us. Hello, are you there? You're on Count on Us.
This is Count on Us. Who do we have there? Is it Salafina? Salafina, you out there?
Yes.
Uh-oh, there we go. Woohoo! Look, I'm getting in the ringing of the bell.
Do it, ring it. I'm going to ring my
right.
cowbell, too. We're so excited. We've been talking for a long time.
All right, Glenard and Woods, is that your school? Did you go to Glenard and Woods?
Yes.
Yeah.
What grade?
I'm in 4th grade.
Love it. 4th graders are my favorite. I'd say that when the 5th graders call, too, but...
Okay, what's your homework?
I'm doing subtracting mixed numbers.
Subtracting.
There's your
mixed numbers,
fractions.
Fractions. It seems like everybody's doing fractions.
That's this time of year.
Okay, read your problem off.
14 3/5 minus 6 3/10.
Okay, so we have 14 3/5
Minus
6 3/10.
minus 6 3/10. Okay. So, looking at this problem, what's the first thing must you do? And how do you pronounce your name again?
Salofina.
Salafina. Oh, you're right on.
was right on it.
Salafina. Okay, so Salafina, what's the first thing that you should want me to write on this paper? What do you think?
You have to find the least common denominator.
Oh, least common denominator. Okay, so I'm gonna write that over here a little bit.
And while he's
What
writing
does-
that, can you tell us why you have to
Yeah.
find that? Can you just subtract these numbers?
You have to make the denominators 10.
I gotta make them 10. Okay, so. This
And
one
let's
looks
just
like
add to
it's
that for the
already
rest of the
10.
students out there who might be watching. When we have two different denominators, when they're not like, they are unlike denominators, we can't just subtract these numbers. We can't say 3 minus 3. We have to have like denominators to do subtraction with fractions.
All right. So now, I turn both my denominators into 10 like you told me now. What should I do next?
Now you should start with one fraction. You should start with 3/10, and since you multiplied 10 times 1 to get 10, you should multiply 3 times 1 to get 3, and the fraction will be still 3/10.
Oh, okay. Now, why did you choose 1 there? Because we were at 10?
Because the LCD is 10, and the denominator is already 10.
There you go. Excellent job. Okay, what's next?
You have to do the other fraction. So since 5 times 2 is 10, then you have to multiply 3 times 2.
It's so great to see you know your facts so well, Salafina.
Okay, and what's 3 times 2?
6.
6. All right. Am I doing it right? Can you see me on TV?
Yes, I can.
Oh, you must be a veteran because I didn't have to tell you turn your TV down or anything. You go.
And look, when she's multiplying, she said the 5 times 2 and the 3 times 2 because ding, 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 there's our whole number, really. Where she multiplied down here by 1, well, we're really doing that up here as well because when you have the same numerator and same denominator, the value is really one whole.
Mm-hmm.
Excellent. Keep on going.
Then you have to subtract the new fractions.
Subtract the new fractions. All right. And what am I subtracting?
You're subtracting 3/10 from 6/10.
And 3/10 from 6/10 is?
3/10.
And I like the way you said that. I am subtracting 3/10 from 6/10. All right. Okay.
So now you basically have the answer.
I have the answer.
Uh-oh.
What happened with these large numbers that you gave me on the other
Oh,
side?
yeah.
Oh, yeah. Okay.
And you have to subtract the whole number.
Okay. And 14 minus 6 is?
8.
8. How about 7? No 7?
Nope.
No 7?
I like it. Stand by your answer.
That's right. Okay. All right. 8 and 3/10. Are we done?
Yes,
How do you know we're done?
because well, it said to simplify, but it's already in simplest form.
How do you know that?
Because the greatest common factor is 1 between the two numbers.
There you go. The greatest common
Wow,
factor.
what
So we
great
put some-
vocabulary you have
Oh,
for
yeah.
mathematics.
There we go. Greatest common factor. My C is running into it. All right. All right.
All right, Celafina, you are our first and only name in our treasure chest. So, what is the probability if we picked a name right now that yours would be the one picked?
I would get it.
Which means it's 100%. 100% chance that you would win. But you know what? I think we have someone else who's coming on the line. So you'll still have a very good chance because there's not that much longer. We have about 15 more minutes, 1/4 of the show left. Keep watching to see if you're the winner. Did you have a chance?
Did you want to try
I was
one
going to say,
out?
did you have a
Yeah.
chance to do any of our challenges?
Sure.
All right. Which one? Did you get a chance to see them when we put them up earlier?
No.
You want the 24, you want the mind builder, or what's my number?
The mind builder was you have 5 students are standing in a line. 3 are boys, 2 are girls. The 2 girls always stand next to each other. So you have to make different ways that they can stand in the line.
Okay.
What's my number gave you some clues where you have to figure out the 3-digit number. And are you familiar with Challenge 24?
Yeah, 24.
Okay. You want to try one of the 24 boards? All right.
Sometimes those are hard to do on the spur of the moment.
Yeah.
So let's just try it, see if you can put one of them together to make 24.
Yeah, I want to do A.
A.
All
Going
right.
with the 1 dot. And what would you like to try? So how would you like to make that equal 24? We have an 8. That's a terrible marker. We have, here's a nice one. We have an 8, a 2, a 6, and a 1. So how can we use these numbers to make 24? And remember, we already actually added them at the beginning of the show. 8 plus 2 is 10, plus 6 is 16, 17. That didn't work. So,
Well, I have 2 ways.
oh,
Okay.
great.
Ooh,
Well,
go
and you know what?
ahead.
We'll take both of them. Let's hear the first way.
6 divided by 2 is 3.
6 divided by the 2, we use this and this, equals 3.
And then 8 times 3 is 24.
I love it. 8 times 3 equals 24.
And 24 times 1 equals 24.
And 24 times 1 equals 24. Ring
All
that
right.
bell.
Woohoo! There
Ring
we
that
go.
bell.
There we
Excellent.
go. All right, Celafina.
So, we're writing your name down for that solution. And
I
you know
got
what?
her.
We're
I
even
got
going to
you.
write it again if you give us another solution that works. That's different from this solution. I'm listening. Go.
I have another one.
I'm listening.
8 divided by 2 is 4.
You know what she's finding? You're finding factors.
There you
Factors
go.
of 24. And you're getting, once you got yourself to 8 times 3 is 24. So if you can figure out how to make the numbers equal 8 and 3, another one is 6 and 4. So she's finding 6 and 4 factors to get her there. 8 divided by 2 equals
4.
4. There's that 4.
All right.
Now she just needs a 6. I
And
see
then
it.
6 times 4 is 24.
6 times 4 is 24. And then you're going to use that 1 the same way?
Yeah, well, 24 divided by 1 is
Uh-oh, look at her. Go ahead. Woohoo! Got the Christmas
You're
bell
being
ringing.
fancy with
All
us
right,
here.
Celafina.
Now she's going to divide by 1 to equal that 24. Write her name down again.
I got it. I
You
have
got
it.
it 3
All
times.
right.
Now, your name's in our Count on Us treasure chest 3 times. What is your chance of being picked out of that treasure chest?
Well, basically 100%.
It's basically still 100%.
Look at you.
Absolutely
All
right.
right.
It doesn't matter if your name was in 10 times. If your name's the only name in there, it's 100%
100%
chance. So we're now down to less than 15 minutes left of the show. You keep watching. I'd like you to think about some of the other 2 challenges and maybe give us a call back and get your name in again. Or tell some of your friends to call for the last few minutes. Work on some of our challenges and your math homework, okay?
Okay.
Thank you so much for calling and
All
keep
right,
watching.
Celafina. All right.
I love it. And this is the point I'm trying to make, that there's always more than one solution. Some of the kids try and call us back and they try to use the commutative property. And we don't accept that as a different way because that's really the same thing. So if you get to this, you can't say to us 6 divided by 2 equals 3 and 3 times 8 equals 24 because that's really the same as this one.
Right.
But this is totally different. I love it. I love it.
And
I
she
love
was
it.
so confident.
Yeah, she had it down.
Renard
And even
was.
wanted to show us that she knew this division and multiplication, both of them. If you divide by 1 or multiply by 1,
Yes.
you're basically getting to the same place.
That's right.
Love it, love it, love it. All right, so where were we?
We were looking at those tiles. We went through, trying to be selfish. You eat
Oh,
all the
we
blue
finished
ones.
that. I ate all my
Yeah,
candy.
ate all
I
the
had
candy.
I had the most pieces. We were good. I was good with that.
Yeah, but I told you that fraction seems to be the big key right now in most of the schools. It seems like everybody's on that fraction mode.
And let's piggyback off Celafina's problem because what a lot of you students are going to end up with right now are problems with unlike denominators. So you may have 3/5 plus 2/5. I mean, no, plus 2/6.
Okay.
Can you add that up for me?
I sure can.
Just like this?
Oh, no.
Can I add this and say 3 plus 2 is 5 and 5 plus 6 is 11?
I could, but it wouldn't be right.
What?
I could, but it wouldn't be
No
right.
way.
Yeah.
Right, we can't do that.
Can't do that.
So basically, we're thinking if we have those arrays, think of it as an array. We have 3 rows with 5 in each row.
There you go.
And here we have an array of 6 I'm not doing that right. I want fifths.
You do.
I'm not doing that right. I want
One whole.
one whole,
There you go.
and I want to divide
it
it
into 5 sections.
into 5 sections. I was thinking of what we were doing before with the arrays. 5 sections. 1, 2, 3,
4. There you go.
4.
That's it.
There's 5.
There you go.
Want to make them more even. And then I have another array. Well, it is an array. Another array with 6 pieces.
Well, keep
1,
it the same
2.
size so it don't confuse the kids. Just to show them how.
Let's just make it.
The reason why we have to. There we go.
It's hard to freehand draw fractions. All right. Make that a little smaller. All right. There we go.
All right.
And because they're different, see, I don't think we really want them different, same sizes, because
see,
we
you
want
got
this
it.
into 5 pieces, and we want this same shape into 6 pieces.
But it's still one. We're still coming out of 1. So what'll
Okay.
happen is, so they'll see that this one is larger than this one, because if we extended this line, it would be here. That's why that 6 is smaller than the 5.
I want my whole to be the same size.
There you go. That's right.
I
We
don't want the
whole.
pieces to be the same. That's what we want
the
me to
whole
do.
to be
right.
the same. There we
The
go.
whole has to be the same size. And this one's divided into 6 pieces, while this one's divided into 5 pieces.
Right. There you go.
All right. And then when we're matching up our pieces, we're seeing how the fifths here are bigger than the 6 here. The 6,
Right.
even though they're both wholes.
There
And
you
we
go.
can't put them together because they're the different sizes.
So just like Celafina said, we have to find our least common denominator.
Now, when you say least common denominator, I can't just find any denominator?
Well, you could, but it'll
Okay.
make life a lot easier for us in the end if we already had the
Okay.
least common denominator.
So, what I like to tell my students, the worst case,
Always.
the worst case, if we multiply 5 times 6,
Worst case.
worst case, 5 times 6 is 30. That's going to be a common denominator
It is.
because they both have 30 as a factor. Okay? As a multiple. So 30 is a multiple of both of these. That is the worst case scenario. Now, there might be other numbers in between if we did the multiples of 6 and the multiples of 5. We're looking for a common 5, 10, 15, 20, 25. Looks like it might be 30. 6, 12, 18, 24, 30. 6 times 1 times 2 times 3 times 4 times 5. 5 times 1 times 2 times 3 times 4 times 5 times 6. The first common number that I'm getting that's the same is that 30.
Right.
So this might not have been the best example to show you, but 30 is the common denominator. And then we'll use Celafina's strategy.
Right.
How did we get to 30 from 6?
And we multiply that times 5.
Times 5.
We got to make it a whole number.
Well, exactly, because whatever we do to the top or the bottom, we have to do to the other one. Whatever we do to the denominator, we must do to the numerator. And really, we're just renaming it. We're not changing its value. We're changing what we're calling it. So we're not going to call it 2/5 anymore. We're going to call it 10/30ths.
All right.
10/30ths.
Okay.
Doing the same up here.
So we multiplied that times 6.
That times 6.
Make our whole.
Okay. Make the whole. Whatever we do to one, we do to the other. Whole. Same number on the numerator and denominator. And here we have 30. 3 times 6 is
18.
18. Now, because our denominator is the same, we can now, see, when we divide these now into more pieces, if we make 6 rows out of it, the pieces get smaller, and we make this 5 rows, then the pieces end up being all the same size. All right, so we divide this and this so that the pieces end up being all about the same size. Very hard to draw, but this one we're going to make into 6. This we're going to divide into 5 rows, and all the pieces end up being similar sizes. So now we can put all the pieces together, and we have 30 pieces together, a total, and we have how many out of the 30?
28.
28.
Okay. Now we're done. Because both of them look even
Well,
to me.
I'm going to say, if I say we're done, then you're going to tell me I'm not correct.
Not right.
Because this is your one answer, but Celafina said the problem says to simplify. All right? You always need to simplify. And sometimes they trick you and you think you're done and you did it correct, and then this answer is not as one of your answer choices. And then you say, well, what? I did it right. Because what else do we have to do?
We have to reduce to lowest terms.
Simplify it to its lowest fraction, the smallest fraction that both of these numbers can be.
And Celafina said we need to find the GCF, the greatest common factor.
So first we were finding the least common denominator, which was actually using multiples. Then we're going backwards and finding factors. See why it's so important to learn your math facts? Because when you get to fractions, if you don't know your math facts, you are in trouble.
Okay.
All right, so what do we want to do here? Because you said they're both even numbers, so right away I said number 2.
2 comes to mind.
2 comes to mind. So let's divide, again, dun, 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 whole number. Whatever we do to one, we do to the other. Now, we may have to do another step after this, but if you don't know, worst case is start with 2. 28 divided by 2 is?
14.
14. 30 divided by 2 is?
15.
15. Oh, I like it.
Uh-oh, I like it too.
15's not even, so we can't divide by 2.
Right.
We could divide 15 by 3 or 5, but this
that
doesn't
don't
have a
work.
0 or a 5 in its ones place, so we can't do that. So I think we're there now.
And I think we're there too.
All right.
That was pretty good.
That was pretty good. But what I want to do real quick, we got time for one more. What I want to do is have two numbers like, let's add 3, 6, and 4 eighths.
Okay.
Okay? Same thing. We have different denominators, so we can't add. They're unlike denominators. I want to use the worst case here, though, and show them what happens.
6 times 8.
6 times 8, all right? We know 6 times 8 is a common denominator, a common multiple, which means we can make it a denominator. 6 times 8 is 48.
Okay.
Okay? We could use 48. And then I guarantee you we will have to simplify and do more steps.
Right.
But if we use the least common denominator, the term that Celafina, boy, we're really using your name tonight, the term that she used, we may get a number that's common that's smaller than 48. Okay. So let's look at the multiples of 6. 6 times 1 is 6. 6 times 2 is?
12.
Keep going.
18.
Keep going.
24.
One more.
30.
30. So 5 and we stop, all right?
Okay.
Let's see if we find something common. We may have to keep extending. We didn't even go up to 48.
Not yet.
All right, because I ran out of room. But you know what? Actually, let's do that. 6, 12, 18, 24, 30,
36,
36,
42,
42,
48.
48.
Okay.
We definitely know we don't have to go higher than 48. Next, 8.
Okay. 16,
16,
24,
24,
32,
32,
40,
40,
48.
40. Now, here's the 48, which is common, but look here. We also have a common number before 48, which is 24. If we used our 24, we get smaller, friendlier numbers where we might not have to simplify. Times 3 times 3. Oops. Times 4 times 4. I'm thinking ahead. Times 3 times 3. Okay. So here we have 24 and 12. Here we have 24 and 12.
Oh. 12 plus 12 is?
24 over.
24.
We have the whole thing.
And we have the entire.
And if you look here, 4 eighths is a half, 3 sixths is a half and a half is?
One whole.
One whole. And on that show, the whole show is now?
Over. Count on Us is gone and left the building. All right.
So remember, we still have Count on Us for the middle school coming on from 5 till 6 o'clock. Hopefully you guys are calling in and give them something to work with. Give them some homework problems and challenge them while they're challenging you. But for Mr. Johnson and myself, remember, you can always count on us.
Welcome to your mini lesson today. My name is Mrs. Jacks, and today we will discuss how to change mixed numbers into improper fractions, and the reverse of that, how to change improper fractions into mixed numbers or whole numbers. Let's go ahead and look at an example. In this example here, once again, it says changing mixed numbers to improper fractions. We have a mixed number here. A mixed number is when you have a whole number paired with a fraction. This one happens to be 3 1/8. We're going to go ahead and change that into an improper fraction. The first step is to multiply the whole number by the denominator. So 3 times 8 is 24. After you do that, well, let me go ahead and show you. 3 times 8 equals 24. You have the numerator here. We're going to go ahead and now add the numerator to our product. 24 plus 1 equals 25. This final answer becomes your new numerator, and the denominator stays the same. So 3 1/8 changed to an improper fraction happens to be 25 over 8. An improper fraction means that the number on top, which is the numerator, is greater than or larger than the number on the bottom, which is the denominator. We can also reverse this. We can change improper fractions back to mixed numbers, and I'm going to show you how to do that now with this second example. Changing improper fractions to mixed numbers or whole numbers. This first one here is an improper fraction. Once again, that means that the numerator is larger than the denominator. The first step is to divide the numerator by the denominator. Okay, so I'm going to set this up as 56 divided by 7. If you already know the answer, you can of course put the answer here, or you can set it up the long way using an algorithm. 7 goes into 56 8 whole times. 8 times 7 is 56. And then with the algorithm, you will go ahead and subtract, and your answer is 0 here, so you don't have anything left over. There's nothing else to continue dividing by. So your answer happens to be 8. So in this case, you can change an improper fraction to a whole number. Let's look over here. This one is a little different. This is 55 divided by 7. So it's one number less than 56. Let's see what happens when we do that. 55 divided by 7, we will do it the same way. 7 goes into 55. It doesn't go exactly 8 whole times. It's going to go in 6 times, and then we're going to have something left over. So let's go ahead and set up the algorithm. 55 divided by 7. Well, I'm sorry, I said 6 times. Excuse me. It goes in 7 whole times. So 7 into 55 is 7. 7 times 7 is 49. To complete the algorithm, you need to go ahead and subtract. 55 minus 49 gives you 6. So 6 is your remainder. Now to set up our answer, the whole number here becomes our whole number for the mixed number. And then the remainder becomes the new numerator. And guess what? The denominator stays the same. So 55 sevenths, which is an improper fraction, now becomes 7 6/7 as a mixed number. Once again, this was a short mini lesson on changing improper fractions to mixed numbers and changing mixed numbers to improper fractions. Thank you for your time.
Minds can achieve anything. We make sure they get to college. Federal student aid provides more than $150 billion in grants, loans, and work-study funds to make college possible for anyone with the mind to get there. Because if given the chance, minds will do great things. Federal Student Aid, proud sponsor of the American Mind. Learn more about money for college at studentaid.gov.
because how many ways are there to solve math? Many!
Your live homework help starts now. Welcome to Count on Us.
What is the length from the entrance to the giant wheel?
All right, so let's add 3 here and see what happens.
First, measure first. I need you to double check yourself. So the second equation for solve perimeter is
2 times length plus 2 times width.
Hello, welcome back to the second edition of the Count on Us, the second half show. I'm your co-host, Mr. Pugh.
I'm Ted Herman. We're here to answer all your mathematical questions you might have because we're called Count on Us. We're at 301-772-0080. Also on the World Wide Web at, just go to www.pgcps.org and come on down the screen till you see podcast and you can follow along on your computer.
Great job. Now, there was a rollover from the last show, the elementary show. I think it was a winner that they didn't announce. You want to announce the name now from us to school? You remember the school?
Celafina, and she goes to school someplace.
Celafina, if you're watching the show last hour, you won the grand prize. Look for that prize come through the mail via our pony system.
Celafina.
As you always know, we always have a challenge for you on the Count on Us show. Once again, we have our challenge 24 question, which is on the bottom. You know, A, B, C, D. As you all know, you must use all 4 digits each one you want to use. Using any operation, addition, subtraction, division, or multiplication. Come up with your final solution of 24. And remember, you must use all 4 digits. And that is a 9, ladies and gentlemen. That is a 9. And we always ask our contestants for just 2 rules with challenge 24. The first rule is you must have a homework question first in order to try challenge 24. And the second rule is please have the problem worked out before you call the show. Please have the problem worked out before you call the show. And if we get no callers later on, I might try challenge for you to show how it's done.
And you know what, Mr. Pugh, right at the bottom of the TV screen it says, call now, 301-772-0080. That's because this show is live. When you call in, you're on the air with us live.
And we have another challenge. It's a problem of the day. Problem of the day reads this way. Would you like me to read? Or you want to leave me to
Oh, no, you're fine. You're doing a great job. You're really smooth.
I'm smooth.
You have a silky voice.
I got a silky voice.
It sounds very
All
smooth.
right, problem of the day. Mrs. Taylor makes a hummingbird food. She uses 4 cups of water for every 1 cup of sugar. How many cups of water does she need if she has 5 cups of sugar? That make you think a little bit. So I'm going to read this question one last time and jot down some important facts, detailing the questions. Mrs. Taylor makes hummingbird food. She uses 4 cups of water for every 1 cup of sugar. How many cups of water does she need if she has 5 cups of sugar? So, I think I know what it is.
Well, you're pretty gifted.
All right?
I got to say, Mr. Pugh, I think you're S&S. You're slim and smooth.
I wish I was slim.
Slim and smooth. I once went to a men's warehouse shop to buy some clothes, and they said, go to the portly section. I thought I had to go dock myself in a port. I was so big. But now, let's get our first caller out there.
Yes.
I know. I'm going down fast. Let's get our first caller in the air because before I sink, I want to come back up to the surface.
David, are you there, David? David, are you there?
Yes.
Hi, David. How you doing?
Good.
David, what school do you attend?
Hello?
David, what school do you attend?
Kenmore Middle School.
Okay, David from Kenmore. What grade are you in?
Huh?
What grade are you in?
Can you turn your TV set all the way down, David?
5th grade.
5th grade?
Yes.
All right, what is your question for tonight? What is your question, David?
What are the prime factors of 35 in the factor tree?
Okay, prime factors of 35. Wow, that's a great, great question in the factor tree. We're going to break this down, okay, David?
Okay.
So I'm going to ask you a question. Can you give me two numbers that multiply together to give me 35?
Hello?
Hello?
Yes.
Can you give me two numbers multiplied together will give me 35?
7 times 5.
7 times 5. Are there any numbers that can be multiplied together to get 5 and 7?
That's it.
That's it?
Yes.
So are those numbers prime?
What makes a prime number prime? That's what I want to know.
Hello?
Hello?
David, before we answer Mr. Herman's question, so when I break down 35 with a factor tree, the two numbers I get is 5 and 7, right?
Yes.
Are those two numbers prime?
Yes.
How do you know they're prime?
Right.
Because they can only be multiplied by 1 in itself.
Boy.
Booyah.
What a nice definition,
So
David.
So the prime factor tree for 35 is 5 and 7. So now, David, can I ask you a question? Can we work on another problem to make sure you understand that skill?
Sure.
Let's do 20. Let's do 42.
42?
We're going to do 42, okay?
Okay.
So 42. Give me two numbers multiplied together. Give me 42.
2 and 21.
Oh, 2 and 21. So I'm going to ask you a question. Can I break down any one of those two numbers?
Yes.
Which number can I break down?
21.
So I'm going to circle the 2 because I can't break that down, okay?
Yes.
So what two numbers can go into 21?
7 and 3.
Oh, my goodness. Are those prime numbers?
Those are all the numbers.
So all those numbers now are prime, right?
Yes.
So my prime numbers for 42 is 2 times 3 times 7.
Yes.
Oh, so you understand prime numbers, correct?
Yes.
All right, David. I want to continue to watch the show. Thank you for calling. And remember, your name is going into our treasure chest. If you continue to watch the show, you can see if you win that prize at the end. Now, did you want to try a challenge 24?
Or the challenge problem of the day.
Or the challenge problem of the day? Anyone? Did you want to try one of those two?
I want to do 24.
All right, now, Dave, what I'm going to do, I'm going to show it to you now, okay?
Okay.
And now I'm going to challenge you, David. Select A, B, C, or D. Write the numbers down and use all operations to get your final answer of 24, okay?
Okay.
So which one you want to select, A, B, C, or D?
A.
Okay, good. The numbers are 4, 7, 8, 8. I'm going to repeat. 4, 7, 8, 8. Write those four digits down and work on it and call us back, okay?
Okay.
Have a great day, David. Good job.
That was awesome.
Yeah, awesome
Name's
student.
already in.
From Kenmore Elementary.
Looking good. Looking sharp. This is prime numbers. You're right about that. Prime numbers are very helpful in our lives.
It is helpful.
It is.
It took a time for me to remember what prime numbers were.
Yeah.
Prime and composite. I forgot.
Oh, you brought them through that problem.
I haven't done that type of math in a while.
Oh, is that right? Well,
Yes.
good to refresh.
Refresh.
I'm happy.
So what are you teaching in your class today? Or this week?
This week we're working on capacity with fluid ounces and pints and quarts. And
So you're doing a lot of
gallons.
conversions.
There you go.
Oh,
That's the word, conversion.
Oh, wow. I don't know.
Mhm.
Okay.
Yeah.
I'm going to leave that alone because I don't know about conversions.
Oh my goodness, we have a new caller out there. Is it Muhammad? Muhammad.
Yeah,
Hi, how you doing, buddy?
fine.
Good to hear from you again. You go to Charles Carroll.
Yeah,
What grade are you in, Muhammad? I forgot.
good.
Good. What grade is that in Charles Carroll? That's Charles Carroll Middle? 8th?
Yeah.
Yeah.
8th. Terrific. What are you guys working on today in 8th grade?
Wait, can you repeat that?
Well, what's your question, by the way?
I'm working with reciprocals,
Uh-huh.
and I took my notes and I know that it's the number you multiply first to get a product of 1, but I don't understand how, like, what number you need to multiply to get the product.
Okay, well, Why don't you give us an example what you're talking about? Maybe we can work through it. You have a number?
Like 3.
Okay. 3.
Right for you, you good.
I think I might be able to reach. If I get that crooked, I'll have you take over.
Okay, you can reach.
I'm feeling like I'm feeling straight today.
Just slide over.
I'll slide over. I'll come to your area.
Yes.
I'm now your neighborhood. Now, here's what Muhammad's got to know. 3 is right there as a whole number, but there's one number we can put right in the denominator that'll give us a fraction now. You know a number we can put down the bottom denominator that will not change the value of the 3?
Uh-huh.
What would it be?
3.
Well, if you put 3 down there, you got 3 divided by 3, which makes 1. That's no good.
So you said, like, if I divide 3 by 3, so, like, I have to divide a number to get to 1?
Well, no, not yet. Not yet. We haven't gotten to that part yet. We're just going to try to put a number like 1. What is 3 divided by 1, Muhammad?
3.
Yes. So, in other words, we have not changed the value of the 3. Whether it has 3 straight up like that or 3 divided by 1, it's still 3. Okay?
Yeah.
So, now, you're talking about reciprocal. Please don't do that. 3 times. Now, the reciprocal means you take the fraction and do what to it, remember?
Uh-huh.
What's that called? Reciprocal.
Flip?
Yeah. So what now goes on top?
1/3.
You got it, Muhammad. You're sharp. And what goes in the denominator?
3.
Good. We'll exchange phone numbers later, okay? Now,
Yeah.
3 times 3 over 1 times 1/3, those are the reciprocals of each other. What makes them the reciprocal flips?
Once.
Well, I mean, what made this reciprocal 3 over 1 times 1 over 3? Do you see how the reciprocals? What's the pattern you see? What's the difference between this and this? This fraction and that fraction.
The 1 is the numerator and the 3 is the denominator.
Outstanding. And now, when you multiply them together, what do you get?
3.
And what's 3 divided by itself? How many times does 3 fit inside 3?
And I also have a question about scale factors.
Yeah, can we just finish this one question for? I don't think we got an answer yet. 3 divided by 3, what does that make, Muhammad?
1.
And that's your definition. You said any number times its reciprocal gives you what? 1. Okay, what was the other thing you asked about? Scale factors?
Yeah. Like I get scale factors, but like, how do you like what does it mean?
What does it mean?
Yeah, like.
Oh, okay. Well, let's get a problem set up, okay? Scale factors. Scale factor, I've seen it a lot with geometry. So, let's talk about similar, not congruent, but similar shapes. Okay, my first shape I drew was a triangle, right? And let's say I had one the same shape, but a different what? Same
different size?
Excellent. So let's say we're going to use our scale factor of give me a number, Muhammad.
7.
Yeah, I don't like that one. Okay, so how about scale factor of 2, give me another number, but not 7. That's awfully, I don't care. You want to do 7? You like 7?
Yeah.
Okay, let's do 7. So we have a scale factor of 2 to 7, which is basically like that. 2 to 7. 2 over 7 means 2 to 7. So if this, give me a number for this first side. Any number.
Can you repeat that?
Good. So let's try 2 right here. All right? And if that side's 2 and our scale factor is 7, then this would have to be 7. Okay?
Yeah.
All right. In fact, I'd rather not even use 7 because it's going to make our situation a little bit too complicated. So let's go 2 to another even number. Get another even number if you don't mind.
4.
Excellent. 2 to 4. So now we have, how do you get from 2 to 4, Muhammad?
The scale factor.
Times what? 2
2
times what?
times 4.
No, we're trying to make 4. 2 times what makes 4?
2 times what? 2 times 2.
Excellent. So in other words, give me another number for the bottom of the triangle, the base. What do you have for that? Any number you like.
2.
Well, you already used 2 here. Let's be a little more variety.
Make it 9.
9. And I'm going to put 18 down on this one. Why?
How'd you get 9?
We just made up a number.
He made up a number. It means nothing. These numbers mean nothing over here. These numbers are made up. But how do I get from 9 to 18? That's the key. Times what? 9 times what? There you go. Same ratio.
But, can I chime in?
Yeah.
David.
Muhammad.
Muhammad.
Yeah.
Then Muhammad, you're in 8th grade, correct?
Uh-huh.
So you heard of this word before? Corresponding?
Mm-hmm.
You ever heard of that word right there, Muhammad? Corresponding parts or corresponding sides? So scale factor, it sets up a ratio or proportion of corresponding parts or sides, okay? So let's go back to the first 2 numbers he gave us, 2/4, which means the same side, same location. So if I say that's A and that's B, that'd be A prime and that'd be B prime almost, because they're in the same location. That gives me my fraction of 2/4. Let's say that is X. So that's B, that's C, that must be C prime. So I know that 2/4 can be equal to 9/X. I'm solving for X. You cross product, that gives me 2X equal to what? 30 what? 6. Divide both sides by 2, X is equal to 18. So scale factor allows you to set things up based on corresponding parts or corresponding sides using proportions. All right?
You must have gotten Mr. Pugh activated because he just flew with that problem. He's like, somebody said the magic word, boom, bam, he's right into the problem like he's going nuts.
David, Muhammad, your name is going into that treasure chest.
You want to try a challenge,
Do
David?
you want to select the China's
he's
24?
my caller, really. Muhammad, you want to try a challenge, please?
Yeah.
Which one do you want to do? 24 challenge or the problem of the day?
Okay, where are the challenges?
It's on the TV screen right now. Look at your TV screen.
You see it?
Yeah, now I see. Okay, I'll try, A.
Okay, write these down. 4788. 4788. You must use all 4 digits using
Wait,
any.
hold on.
Yes.
Wait, can I go to D, the hard one?
Oh, that's what I'm talking about.
Oh,
yes.
my God.
That's what I'm talking about.
Oh, yeah.
Try that hard one,
Muhammad. I knew Muhammad was a tough guy.
All right, Muhammad, the D.
Oh, my goodness.
It's 3, 4, 4, 9.
Let me put that down. 3,
4, 9.
I think I know the answer.
Well, let's go ahead and find out. All right, Muhammad. Use your 3, 4,
No,
4, 9.
he has to work it out first, right?
I thought he said he already knows the answer.
4.
You already know the answer, Muhammad?
9 times 4.
9 times 4 is 36.
And 3 times 4 equals 12.
Oh, Muhammad, you're a smart kid.
And 36 minus 12 is 24.
Oh, ding, 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 ding.
D is the hardest one up there, and he got it!
That's what we said. We said D was the hardest one. Intern.
Whoa.
Muhammad, your name is going in that treasure chest not once, but twice. From Charles Carroll.
At Charles Carroll Middle. My goodness.
Muhammad, continue to watch the show. If any more questions, please give us a call back. Also, Muhammad, if you want to try the second word problem of the day, let us know, okay?
Okay.
Have a great day, sir.
He's in there twice?
You did an awesome job with that.
Unbelievable. I'm so proud.
Mr. Hum.
So proud. So proud.
All right, we'll go to the next caller.
Yes, sir.
We have quite a few callers.
We got a lot of callers there. I'm so proud
I
of you.
love my secondary
Mr.
shout.
You bring out the best in me.
All right, caller, are you there? Caller, are you there? Hello?
Hello?
David?
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 Hello?
David?
Yes. Hello?
Can you hear me now?
Hello?
Can you hear me now?
Hey.
Hi, David.
What's up?
Hi,
How
David.
are
How you doing? David.
Hi.
Hi, Dave. How you doing,
right
David?
there.
How you
I
doing,
heard
David?
him. He's right there.
You calling back for a challenge, David?
Yes.
Okay, what were your numbers
I did the
again?
24 challenge, and can I do A and D?
Okay, let's try the A first.
He can do two?
Okay, my first.
Is that allowed?
I have two.
All right, but pick which one you want to do first.
I think you're off sides.
Okay. 8 minus 7.
Oh, so you doing 8, 8, 7, 4. So 8 minus 7 gives me 1.
And then 4 minus 1 equals 3.
So 4 minus 1 equals 3.
And then 8 times 3 equals 24.
Oh my goodness. No, you didn't. David. Go. It's your birthday. Go, David. Go, David. Let me stop before I hurt myself. Good job, David. Your name is going in the treasure chest not once, but twice. Okay, David?
His answer was right, too. That's amazing. Unbelievable.
Good job, David.
Whoa.
Thank you for calling back. Now, David, next time you call back, try to solve the other riddle. So I'm going to let you go now, and I'm going to read this to you guys for TV Land so you can see. Thanks, David.
Wait.
What?
Bye-bye, David.
Can I do D?
No, do one at a time. Thank you, David. My interns need to push the button. Bye-bye, David. Thank you so much. Okay, here we go. Problem of the day. Mrs. Taylor makes hummingbirds food. She uses 4 cups of water for every 1 cup of sugar. How many cups of water does she need if she has 5 cups of sugar? All right. So people out there, try to solve this riddle as well as the challenge 24. Come on, put them thinking caps on, mathematicians. And my nickname now is not Mr. Pugh. It called me Mr. Digits.
Mr. what?
Mr. Digits.
Mr. Widget?
Digits. Yeah, say it again.
Digits. Don't say it again. 'Cause I got you all over my face. Okay, next caller out there is John.
John.
Yes.
Whoa, excuse us, John.
Oh, press me back against my chair, John. What school you at, John?
John, what school do you go to?
Kettering Middle School.
All right, Mr. Salam. Tell Mr. Salam and Miss Michelle, Mr. Pugh said hello.
And what's your problem today, John?
-3/8 minus -5/8.
Okay, you want to write that because you're so good. You're so gifted with your handwriting.
John, you said -3/8 minus a -5/8. Is that your problem on the TV screen, John?
Yes.
Once they show, that's
Just
it.
like that? Oh, nice job, Mr. Pugh.
I try my
Way to
best.
go, John.
I try my best.
Well, let me show John my favorite thing here. You have a subtraction of a negative number. Subtracting of a negative number. So let me show you my special trick. I like to do this once a show if I can. Watch this, John. You're going to be impressed.
Watch this, John.
Oh, my goodness.
This is awesome, John.
This is unbelievable.
You can't control yourself,
Most
John.
people
Watch this.
are calling in from all over the world
John,
to see this part.
is like the thing right now going on in math.
There you go. There's a subtraction sign, and then I'm going to make a negative sign. So now my negative sign is going to come out there in green. But what you can do when you have them side by side, subtraction of a negative. Subtracting a negative is just like oh my gosh, it makes everything adding a positive. Subtracting a negative is the same thing as adding a positive.
Oh my goodness, John, that's the new thing going on in math.
I'm telling you. So I'm going to rewrite the problem. -3/8 plus a +5/8. Now, are both the signs the same, John, or different?
Different.
Yes. So do we add those together or subtract them from each other?
Add them.
We're trying to add them, but we have a negative here. Oh, I hear whispering going on. John, stop whispering, please. There's a negative sign there and a positive sign here. So don't you have to do subtraction?
Yes.
And which one's going to control the answer? The -3 or the +5? Yeah.
-3.
Right, the +5. So we're going to have a positive answer because the 5 is a larger absolute value. It's a larger distance from 0. So let's go ahead. What's 5 minus 3, John?
2.
John, why are you talking about break time? John, I'll be doing the show here. Okay? What's 5 minus 3?
We've been here for 10 years, John. 10 years, John.
John, you still there?
Yeah.
What's 5 minus 3, John?
2.
Yeah. And our answer is going to be +2/8. But that's not really the answer, is it, John? What's wrong with that answer? What's wrong with leaving it like that with 2/8? It's not what?
Simplified.
Divide.
Oh, good job. He said simplified.
He did or you did?
He said simplified.
Okay, good job, John.
See?
I'll give you all your props.
I believe in John. I believe in magic.
Simplified. So what number divides into 2 and 8 at the same time? Do you know what number fits into 2 and 8?
2.
Oh my gosh.
Oh my
John's
goodness.
coming on strong.
Oh my goodness,
What's
John.
the answer going to be? 2 divided by 2 is what?
1.
Okay.
And 8 divided by that same 2?
4.
Oh my goodness.
So what's our final answer?
+1/4.
Oh my gosh.
John
I'm so
from
proud.
Catherine Middle School.
Oh, John's
Miss
going
Michelle and Mrs. Salam. How you doing? And Miss Hampton from Science Department. John, your name is going into the treasure chest for answering the question.
And please call back after the break, John, with any answer you have for the challenge you might have. Because right now, folks, stay tuned. We have a short break. Come on back.
And
we'll see you
Olivia,
right
stay
here.
on the line, Olivia. We'll get to you next as soon as
Don't
we
hang
come
up,
back.
Olivia. Keep your percents flying
Right
high.
after the break,
Yeah.
Olivia's taking your questions. See you after the break.
Hi, I'm Cameron from Samuel Ogle Middle School, and today's email question is from Ted at Rockledge Elementary. Ted wants to know the area and perimeter of a rectangle that measures 3 inches by 6 inches. Well, let's start with the perimeter. The perimeter is round. So we add all the sides. Okay, so we know that if 3 inches is on this side, then 3 inches is on this side. And if 6 inches is on this side, 6 inches is on this side, because the opposite sides are equal. Now we add 6 plus 6. 6 plus 6 equals 12 inches. And 3 plus 3 equals 6 inches. Now 12 plus 6 equals 18 inches, which is the perimeter. Now we do the area. The area is the inside. So we can either count the squares or we can do length times width. And the length would be 6 inches. And the width would be 3 inches. So let's do both. First, we'll count the squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So now we know that we have 18 inches squared since we used the squares. And the same thing goes for length times width. So now we do 6 times 3. 6 times 3 equals 18 inches squared. And this is the area. Well, Ted, I hope that was helpful to you. So that's Cameron, and see you next time.
Wait a minute. That's wrong. All people are people.
Take the time to get to know people, and you'll see that all of these labels are false. Don't let prejudice shape your view. Stereotyping is wrong, and it hurts all of us.
Stop stereotyping.
A message from your American Muslim neighbors.
When I was a kid, I dreamed of being a stuntman.
I went from dream to dream pretty quickly. I wanted to be a cowboy. Tom Cruise in Top Gun.
I dreamt of being a nun.
Actually, before that, it was Popeye.
Malaria kills more than 2,000 children a day.
Text NET, N-E-T, to 85944 to make a $10 donation to Malaria No More.
Oh, messaging and data rates may apply.
Let's make malaria no more.
Welcome back to the second half of our show. Once again, I'm Mr. Pugh.
I'm Ted Herman.
I'm also known as Mr. Digits.
I'm Ted Herman, and we're here to answer all your questions and control our earphones and earpieces at the same time. Call us at 301-772-0087. I got to ask the callers out there, does anybody see any tape hanging on my ear?
I did.
I don't see no tape hanging on my ear, so I don't know what the problem is in my ear. But now I have a tapeworm.
I want to call it. You all doing an excellent job this evening by watching the show, calling in with your questions. We want to continue that because we have a special listener tonight. His name is Devin from Roosevelt High School. Continue watching us, Devin. We love you. You can give us a call, Devin. So we're going right to our next caller.
That's like a memorial to Devin.
Our next caller, Olivia. Hi, Olivia.
Hi.
Thank you for waiting through our commercial break.
Yes.
Do me a favor. Turn your TV all the way down.
Okay.
Thank you. I will give you a few seconds to turn your TV all the way down.
Olivia, don't you go to St. May's?
Yes.
Oh, my gosh.
How did you know that?
Do you have teeth?
Do I what?
No. What grade are you in? I'm sorry.
Olivia, what grade are you in?
7th.
Well, where is St. May's anyway? I never heard of that. Where is St. May's located?
It's in Landover Hills.
Okay.
Oh, okay. Is it a private school or a regular school?
It's private.
Oh, nice. Okay. Well, I'll give you all your attention to Mr. Pugh. He'll answer
Why
all
give
your
it to
questions.
me for?
I thought you wanted to get a talk to
Olivia.
You greeted her.
Okay, hi, Olivia. What's your question, Olivia?
Okay. Well, I have to find the percent of these two numbers.
Okay, give me the question.
Okay. You want the question out of my book?
The question you have a hard time with, Olivia, yes.
Okay. It says of 1,080 pennies in
1,080 pennies
in Jamal's collection, 270 are Canadian.
270 Canadian.
What is the percent of Canadian pennies?
Oh, what's the percent of 1,080? Oh, my goodness. You can do two things. You can divide, right?
Wait a minute, Olivia, do the Canadian pennies speak French?
Olivia, did you get that joke? Did you get that joke he just said?
No.
I didn't get it either. Okay. So, Olivia, we need to find the percent of how many of these are Canadian pennies, correct?
Yes.
So I'm going to need help from my partner. I'm going to ask him to use a calculator.
Okay.
Oh, yes.
Okay, so I can say 270 over my total 1,080. So it's 270 divided by 1,080 gives me what, Mr. Herman?
It gives you your batteries are low.
So hit
Recommend
clear.
change the batteries.
Hit clear.
Okay.
Now
Okay, 270 divided by 1,080
equals
a decimal point.
That gives
25.
me 25 hundredths. So now, so I know that 270 out of 1,080 gives me 25 hundredths, but I need to transfer now. I need to convert my percent and my decimal, excuse me, my decimal into percent. So I got to move my decimal point 2 times to the right. So that gives me 25% of my. So guess what? The Canadian coins represent 25% of Jamal's total coin collection.
Now, can I jump in? If somebody came along to you, Mr. Pugh, and said, I see the 25%, but wouldn't that be 1/4 of the total collection?
Yes, it
would.
would
Would they be wrong or right?
That'd be correct.
That'd be okay? How do you get that?
Because percent is based out of 100.
Ah.
So it'd be 25 over 100. It reduced down to 1/4.
Oh, there's 4 quarters.
There's 4 quarters in $1.
$4.
Oh! Oh! Olivia, did you catch that too?
Yes.
Okay. So did you understand the problem I just showed you?
Yes.
So now I'm going to go back to the problem and review the problem for you really quickly. So we know Jamal had a total of 1,080 pennies. Out of those total pennies, 270 were Canadian pennies.
Yes.
So I need to find the total number percent of Canadian pennies out of his total population. So I took my part, which is 270, divided by my whole number is 1,080, and I got 25 hundredths. But I need to convert my decimal into a percent. And I know percent is based out of 100. I move it 2 times to the right. That gives me 25%. So Jamal's Canadian collection is 25% of his total collection. Okay?
Yes.
Wow. That was a lot of talking and explaining this now. I'm tired, and I need a drink of water. Devin, give me some water, please.
Well, you know what? Olivia gets her name into the treasure chest.
And Olivia, continue to watch the show. Your name goes into the treasure chest.
She going to try a challenge today?
Ask Olivia, do you want to try a challenge?
Sure.
Okay. This your first time caller?
Yes.
Shake the bell for the first time caller. Oh, that's doing. Shake the. Yeah! First time calling. We welcome all students. We welcome all students. That's why we're here, for the betterment of all students. And Olivia, don't let it be your last time calling either. We're here every Monday and Wednesday from 4 to 6. 5 to 6 is a secondary show. You can see even 1 hour pretty faces all the time. Or 4 to 6 hour elementary show, okay?
Mr. Pugh don't get out of the house very often, but when he does, he's explosive.
So, Olivia, this is our challenge 24, okay?
Okay.
You can select A, B, C, or D. Now, there's certain rules with this. You can select, if you select one of the 4 cards, you must use all 4 digits. You can use any operation you like, and your final answer, your solution, I should say, must be 24.
Okay.
All right?
Yes.
Now, I can show you really quickly how one of our contestants did it earlier. One of our students did it earlier, just to model, because great teachers always model expectations, okay?
Yes.
So one of them was 4, 7, 8, 8. So I think one of them said 8 minus 7 gave me 1. So I canceled 8 and I canceled 7. Another one said 4 minus 1 gave me 3. I canceled 4. So they said 8 times 3 gave me 24. And that's how they came up with the final answer of 24, okay? So that's a model for you, Olivia. And have a great time trying to solve the problem. See you later.
Okay, bye.
Bye.
Wait a minute. Did Olivia solve the problem?
I said trying to solve the problem.
She's trying to solve the problem.
Yes.
So
I modeled for her, yes.
She's going to come back and call back
She's going to call
later.
back
Oh,
later.
I thought maybe just
because she's going to select either A, B, C, or D. And she's going to write those 4 digits down right now. And she's going to work on the problem at home and call us back later.
Fantastic.
And remember, Olivia, that's a 9. That's a 9. Yes, it's good to say that's a 9 looking at me.
We have some more callers out there. But you know what? Before we go to the next callers, Mr. P, I got to ask a philosophical, theoretical, hypothetical question.
Wow, that was a lot in that one question right there.
Are Canadian pennies even able to be used in our American society? Because I sometimes go through the cafeteria line at school, and they'll say, no, I want regular pennies. You can't use Canadian pennies here. I don't know what the deal is. Are we allowed to use them here?
If they say no, I'm apparently not.
Okay, next caller. Is that John? John. John. John's calling back with a challenge. John?
Yeah.
Hello, how you doing?
Good.
Good to have you back with us on the show again. Are you going to try a challenge now?
Yeah.
Which challenge you want to try? 24 challenge or prom of the day?
You better leave your name in there.
24 challenge.
24 challenge. Challenge. Okay, John, what's your challenge? A, B, C, or D?
Can't see the chart.
Can you see now?
D.
D as in David. Dag. Here we go. So you have a 3, 4, 4, 9. Okay, John, this is a tough one. Give it to me.
9 times 4 is 36.
9 times 4 is 36, correct?
4 times 3 is 12.
4 times 3 is 12.
36 minus 12 is 4.
Did we do this already? You did this already, didn't you, John?
36 minus 12 is 24.
Did you do this already, John?
What did you say?
Did you do this already?
Yeah.
Oh, you can't get it. You can't win for the same thing because you just solve it a different way. You already got rewarded for that. Okay.
Okay.
So try another one. Try a different way. Use the same 4 digits. Try to do it a different way.
Give us a call back as soon as you can.
And give us a call back as soon as you can, John.
Oh my gosh, Celafina called back from the first show.
She's the winner from the first show.
She's the winner from the first show, Celafina. Bernard and Woods.
Bernard and Woods.
How you doing, Celafina?
I'm doing fine.
I bet you are. After winning that prize for the last show, make sure you share some of that prize with me.
Is Glen Arden Woods a talented and gifted school?
Yes.
I thought it was. I have some students over there who I had last year in my class. My goodness.
We took one of your teachers from last year at my new school. Did you know Mr. Dupree?
Yeah. No, Mr. Dupree left.
I know. He's at my school now.
Let him go back.
No, we love him too much.
Well, that's nice.
Okay, Salofina, how can we help you?
I had a question about prime factors.
And what is your question?
What are the prime factors of 70?
Of 70? Oh, great question. Are you watching a TV show? Can you see us on the show?
Yes.
Say, look, I have 70 up here, okay? We're going to make a factor tree, okay? We're going to show the factor tree in a few minutes as soon as my man Devin pushes the button. Okay, now here we go. Salofina, here's 70. Give me 2 numbers multiplied together to give me 70.
10 and 7.
Oh, I love those 2 numbers. 10 and 7. Now, I'm asking you a question. With those 2 numbers, can other numbers multiply to give me those numbers? 10 and 7?
10 can.
Okay, so there's no numbers multiplied together to give me 7, correct?
Yes, no 2 numbers can give you 7.
More than 1 and 7. So can I circle that number?
That's prime.
Because that's a prime number, correct?
Oh, my goodness.
So what 2 numbers multiplied to give me 10?
5 and 2.
5 and 2. So are 5 and 2 prime numbers?
Yes.
So I can circle those numbers, correct?
Yes.
Can I break 5 down even further?
Huh?
Can I break 5 down even further? Are there any other numbers I can break 5 into? Any numbers multiplied to give me 5 besides 1 and 5?
No.
What about 2?
No.
What about 7?
No.
So therefore, the prime factors for 70 is 2 times 5 times 7.
Can I jump in on one thing?
Yes, jump in. Tag team, back again.
Celafina, I'm sorry, Celafina. What distinction does 2 have? It's a prime number, but it's the only prime number in the whole prime number world of prime numbers that is special. Why is it special?
Good question. See, I'm not on that level.
What'd you say?
What kind of number is 2?
Because it's the lowest number.
True, but it's also a special kind. Is it odd or even?
It's an even number, but it can still be prime.
Absolutely. It's the only prime number that's even. boy, Cellophana knows her stuff.
She's awesome.
At Glen Arden Woods. Oh, my goodness.
So thank you, Cellophane.
Did she get her name in again?
She won last show. She can't.
Well, she get her name anyway, but she can't win.
All right. Paybacks. It's a killer. Let's go to the next caller. Next caller, are you there?
Yeah.
Hi, John.
Hi.
John's back?
You called back for the China 24?
Goodness.
Yeah.
Same numbers?
21, 21, 13, 24.
Ooh,
okay.
He's stepping it up.
21, 21, 13, and 4. Talk to me, John.
21 minus 13 is 8.
21 minus 13 is 8, correct. I'm waiting for you. Excuse you.
I'm out of yellow papers.
Minus 4 equals 4.
You say what? 8 minus 4?
Yeah.
8 minus 4 equals 4, correct? Oh, John, you were so close.
Oh, you missed it by
John,
1.
you missed it by 1, John.
Oh.
Keep trying, John. Call us back.
That's rough. Well, guess who's back on the air with us again? Olivia.
Olivia's done. Olivia's back. Hi, Olivia.
Hi.
How you doing?
Good.
So do you want to try China's 24?
Yes.
Oh, did you have a question?
Oh, no, I want to try a challenge.
All right, what number did you use?
I used 7, 13, 5, and 23.
Okay, Olivia, talk to me. What to do?
Okay, I did 13 minus 7.
13 minus 7 is?
6.
6 counts out to 7, calls out 13. Go ahead.
Okay, and then I did 6 plus 23.
23 plus 6 is?
29.
Uh-oh. Get it ready. Get it ready, because I see what she's about to...
And then I did 29 minus 5.
Which is?
24.
Bing, 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 bing. Olivia, the mathematician. Good job. Your name is going in the chest, not once, but twice, because you solved the problem even nice. I tried to rhyme, but that's my job. It didn't sound good. Somebody be quiet. Hit the log. Good job, Olivia.
Thank you.
Awesome job. Continue to watch the show. You might win.
Our students in Prince George's County Schools never give up. Next caller is David. David!
Yeah.
From Kenmore Middle.
You must know how to dial that phone fast. You're good, man. What's up?
Good.
He won that challenge of the day.
Challenge of the day?
Yeah.
Are you like psychic?
Which one, David? Which challenge?
The problem of the day.
Uh-oh.
Problem of the day.
Uh-oh.
First person to try that today.
Okay, David, I might be a little biased, David. You can just write, David, I might be a little biased here. So tell me, David, Miss Taylor makes hummingbirds food. She uses 4 cups of water for every 1 cup of sugar. How many cups of water does she need if she has 5 cups of sugar?
She needs 20 cups of water.
Oh, my goodness. You are so right. But can I ask you a question?
How do you do that?
How you solve it? Your answer is correct. So, David, your name is going in the treasure chest not once, but twice for answering this question right. But tell me, can you tell me how you solved that question?
Well, because 4 cups for every 1 cup of sugar. So 1 cup of sugar is 4 cups. 2 cups of sugar is 8 cups. And then 3 cups of sugar is...
So you did this, David. You did that, correct?
Yeah, I just really did 5 times 4.
Oh, my goodness. That's repeated addition. Yeah, I think I did that right. So, David.
Yes.
So, David, so you said 5 times 4, correct?
Yeah.
Because for every 1 cup, you get 4, right?
Yeah.
That's not bad, Dave. I'm trying to solve 1 cup. You're right, 5 times 4. Gave me 20. Is there a way you can solve this, Mr. Ted?
4 cups of water for every 1 cup of sugar.
Because 20 is correct. I'm just trying to solve it mathematically.
Right. Well, 4 cups do make 1. No, let's see. I would do a table. 4 to 1.
Oh, yes. Make a table.
An in and out table or some kind of XY table. Yeah.
Well, they're playing with us now. Thank you, David. Excellent job, okay?
Okay.
Think we have time for one more caller out there? John!
One more caller, you sure?
I don't know. We could have 3 or 4. John, depending on how fast we talk. John, are you there?
I talk pretty fast.
I noticed.
What's that?
John tripped over the couch or something. You okay, John?
Yes.
Oh, boy, you called back for a challenge?
Yes.
Which challenge do you want to try, John?
5, 23, 7, 13.
Is this the one he tried before? Is this the same problem? I hope he can do it now.
No, this is a different one.
Oh, my goodness.
He tried the 21, 21, 13, 24.
So he's trying.
Now, John, you got to give us a different way from the previous caller Olivia gave us, okay? If you gave us the same way Olivia sold this, we can't count that, okay?
Okay.
So, talk to me.
5 plus 7 is 12.
5 plus 7. Oh, I'm about to write 12. 5 plus 7 is 12. Cross out 5 and 7. Go ahead.
23 minus 12 is 11.
23 minus 12 is 11. Correct.
And then 11 plus 13 is 24.
Oh, my. Shake the bell for my man, John. Persistence. Persevere. That's mathematical practice number 1. Great job, John. Way to stay on. Way to keep trying. Way to keep fighting. Keep showing your work. I love you, John. And your name is going in the app, in the treasure chest, not once, but twice. Not twice, but 3, because you're awesome. More than you and me, including Mr. T. I'm rhyming for free. Mr. P live on that CO. Okay, I'm done.
I like ringing the bell. Catch me on the street with my bucket out there in front of some of the stores. John got her name in there, got his name in there again. Oh my goodness. Do we have time for Geraldine?
Do we have time for one more caller? Let's try pushing it. Hi, Geraldine.
Yes.
How you doing? How can I help you from Glendown Woods? What's your question?
Welcome to the Mr. Pugh Show.
I need help on adding and subtracting. Well, I need help on adding mixed numbers.
All right, what's your number? Give me your question.
What? What's the question?
Give me your question. What's your question?
The question is 5 1/4. Plus 10 1/3.
Okay. Now, Geraldine, there are certain rules we must follow when we talk about adding and subtracting mixed numbers or fractions. The first rule, I'm going to always change my mixed number to an improper fraction, okay? So I'm going to take my whole number and multiply my denominator. And then I'm going to add it to my numerator. So that gets me 21 over 4 plus 31 over 3. The second thing is, I didn't have my denominators the same. So my same denominator is 12. So in order to get 12, I'm going to get 63 over 12 plus 124 over 12. That gives me 63 plus 123. That gives me 187 over 12.
Outstanding job. So now it's time to pick our winner today, and we have to be rolling out here because we have another show right after this.
Give it to me.
So here we go.
That gives me 1 and 5 12.
Oh my goodness. Go ahead, Mr. Pugh.
And the winner is
Olivia!
Remember, every Monday and Wednesday you can count on us.
Count on us. Sorry.
You about to have Olivia supposed to win?
Why? I told you I was going to.
She go to take me.